Our next speaker is going to talk about human-centered authentication. Jeremiah Still is at Old Dominion University, which is also here in Norfolk, and I will hand it over to you.
All right, thank you. I think one of the things that we run into when we go to human factors conferences that focus on cybersecurity, which seems very much related to cyberpsychology here today. One of the things we find out right away, a lot of people are eager to work in cybersecurity, but they don't know what problems to work on. All right? They're afraid of the technical boundaries that kind of impede them from getting into this. One of the things that I've noticed when I've tried to build the point for the human factors side of this is there's not a lot of really good data. If you look at like the Verizon report to AT&T, they'll say, like, it was human error. That doesn't really get us anywhere, right? So we need to train the people that are recording these human errors to actually classify them appropriately so we know how to address the issue. So you can imagine planes going down. Well, it wasn't mechanical, it was the human, right? But without any black box data, how are we going to make any changes, right? So I think that's kind of transitioning over. So what I focus on, my specialty is human-computer interaction. I have a cognitive psych background. Today I'm going to focus on the design of interfaces. So that's kind of my niche here, okay? So obviously this is a big problem for society and a big focus right now, cybersecurity. That's an easy pitch for here, so I don't have to go into the number of attacks and that we hear again and again and again typically for these talks. But what we're seeing is that users are embracing the digital environment they live in. They're accessing their bank accounts, their health records. We have intellectual property at universities that are out on servers, and they're only protected behind a gate. Okay? So all you need is a password to get in. Okay? But oftentimes, the users don't respect the security that goes along with this great convenience, this digital convenience that we're experiencing. And they for sure don't understand the varying degrees of risk that are associated with what they're doing online. So given that we have a variety of technical backgrounds, I like to always start with something a little more concrete. So let's think about something physical, like a safe, all right? So say that you're having a lot of break-ins in your apartment complex, so the local police officer says, why don't you use a safe, okay? So things that you want to know when you're trying to implement this safe to your users, because you want them to keep their papers, like their checkbooks and personal stuff, locked up, their jewelry, okay? Do they want to use it in the first place? Okay, so are they actually going to put stuff in there, or are they going to leave it on their desk in the open, right? You need to know, do they know how to implement it correctly? So do they actually lock down their safe to the wall, the floor, or have you now offered all the thieves a nice way to kind of get to all your important information very quickly, all packaged up in this nice metal square you can lug off, right? The next thing is, can they remember the passcode? If you're asking somebody to put all their valuables in one place, are they terrified that they're going to forget their code? And the sequence is kind of tricky, like the interaction is tricky. So they just write down like in a very clear way how to access it and then put it behind the safe on a sticky note because, right, that makes them feel comfortable. Nobody else is going to look there. That's just their secret. Okay. Do they understand the limitations? Safes are not there to keep your valuables like protected, indefinitely. Safes are a deterrent, and they're rated on how long it takes you to cut through the material with a torch or to compromise the hinges with a sledgehammer using brute mechanical force, right? So they need to understand the limitations. Now, we can take all of these ideas, right, and apply them to whatever type of virtual security system that we're thinking about and see if we can get at some of the user's perceptions and maybe identify some of the usability issues that are in play so we can correct them. So whenever we start thinking about redesigning a system to make it usable, we look to one of our forefathers of human-centered design, Don Norman. And this is a quote from him. He said, the needs of the user should dominate the design of the interface, and the needs of the interface should dominate the design of the rest of the system. Okay? So as designers of systems, okay, we need to consider the user's task, their needs, the environment this thing is operating in, and the user's abilities. At every stage of interface development. This is not something that we want to put stickers on at the end. This is not something where we want to implement a bunch of training. This will fail. And this has failed many, many times in history. You can look at the human system integration literature over the last few decades. Okay, so we need to design out. Probably a lot of you on the cyber side are saying, we're finally getting negative use cases early on in the design process. We need to make sure that we're keeping the human involved throughout the entire process. Okay, so we all would agree that the users are the weak link, right? But that's why the system exists. If we had no users, it would be completely secure, but why would we pay millions and billions and trillions of dollars, right? We have technical systems to facilitate our ability to do things on a day-to-day basis, right? And the security is to protect our valuables, our assets. So we have to think about how much value is this particular asset that we're dealing with, all right? How much security does it need? It's probably not a blanket solution here. And this is, I don't want to get off on the technical side, but what we do need to consider is that users' primary goal is just to use the system to facilitate their tasks, and the cybersecurity focus is to protect them. We need to strike a balance between those two viewpoints to make the system successful. I think a lot of you going at the VP level in cybersecurity going forward, you're going to struggle a lot with this, from how much is it going to cost, you know, what's the real risk here, what's the perceptions, and blah, 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 right? So that's really the fun part of what we're doing in cybersecurity, is striking this balance, okay, between these two worlds. But we need to really start to understand the users, their strengths, and their weaknesses to do a good job at this. So this leads us into this idea of maybe usable security is an oxymoron. Maybe it's not, you know, really feasible. We can look at, say, conventional alphanumeric passwords, for example. As you increase their complexity, they become longer, they're ever changing, the usability seems to decrease, right? We all experience this. And now, like somebody mentioned earlier, it's really frustrating when we invest in creating a really strong password, right? And now we have to change it every 3 to 6 months, when the password should be able to last hundreds of years, okay, based on brute force justification. Now, is it true that brute force is really how people are attacking passwords? No, right? Absolutely not. Why do we stick by this? Why do we stay by this? Well, companies have to meet some business standards and practice and maturity, okay? And one of these is that you're following these brute force expectations. One of the things with creating a new policy or following business practices, they're very, very slow to change, and cybersecurity is very dynamic and quick, so it's a challenge. But from a user perspective, so I should say, you know, slow down a little bit. What's brute force? What's this bit strength kind of validation that we're talking about? Is that you evenly distribute passwords across your entire dimensional space. So if you think about symbols, spaces, whatever you're putting in there, they should be using them about equally. Do they do that? No, they cluster, right? So people like to use things like password, like I said before, Ninja, Monkey, okay, 1111, and get into a lot of people's gates, and the apartment complexes using that, okay? So they cluster. Why? People rely on cognitive shortcuts or heuristics to remember their password, right? And there's a number of other things that go into this. We know that up to 50% of passwords are reused, and some are reused up to 4 times, probably more now. This is based on some data from 2011, which is really from 2007, right? We have more and more online services that we have to log into. What are the problem here? What's the root problem? It's cognitive effort, right? So we can list a few things here quickly. First, you have to recall your password from memory. If I was to ask my students, okay, and I do this usually at the beginning of every semester, I have an essay exam for this test, and I have a multiple choice. How many people want to do an essay? Nobody raises their hand, right? How many people want to do a multiple choice? Absolutely. Why? The answer's in front of them, right? And you know, it depends on how well it's written, the multiple choice test. I have some pretty good decoys myself, and how you're grading the essay. But it's easier to recognize something than to pull it from memory. The second thing is that it's always changing. So it requires additional working memory resources to consolidate this information. And we're often asked to generate novel content, something we haven't used before, and we're under time pressure. What do we mean by this? Well, for me personally, you might have 20, 30 emails you got to get to before office hours starts, when you get slammed, and then you got to go to class, then they have a lab meeting. So you're under the gun, right? You got to get this done now. And so you might not do a very good job, and it's very effortful. And it's often hard to make meaningful passwords as well. And I hope we move away from these complex password requirements like we have now, so we can create more meaningful passwords and increase compliance, but that's a whole nother talk. So before I move forward, I want to take you through a human-centered design activity that we often use in the lab when we're trying to create some new prototypes or solutions for companies or for publication. And what it does is allows us to kind of think about the strengths of humans and think about the strengths of computers. And I want you to contrast them with one another. So go ahead and just feel free to yell out, what's a strength of a computer, okay, that's not a strength of a human? So what's the strength of a computer? Some huge storage, memory, right? This is kind of a nice function allocation task for, huge complex number processing, right? Imaginary numbers and okay, very well-structured data. You can pull out very quickly, do matching, and say this is what I'm looking for. Yeah, repetition, right? It's not moody. Okay. So how about humans? What are humans really good at? Now, this is important, right? Or we're all out of a job here in the next 10, 15 years. So what are we good at that computers aren't good at, right? Relationships. So what else? Yeah, perception, semantics. Okay. So maybe being able to problem solve, right? Fuzziness, okay. Creativity, flexibility, okay. Maybe ethics, right? So we can generate a list, and we come up with something like this. This is pretty much what we were hearing today. And so from this list, we can kind of launch into going forward with human strengths, right? And one of the human strengths that we have is object recognition. And this is something that MIT and Georgia Tech were swearing to NSF, we're going to be able to have robots recognizing objects in the 80s. Like, it's going to be a solved problem. Did that happen? No. There was a lot of artificial intelligence funding in the 90s, and this has been fading ever since because it's empty promises, right? But I don't want to step on any toes, I'm big data folks. So one of the things that we can move forward with in terms of authentication is looking at graphical. So we can then use to our advantage our ability to recognize objects, in particular faces. So the brain actually has fusiform face area, so it's a specialty area that some scientists argue is specific for recognizing faces. So this is even better, right? So what they did here, they had young people's faces. The system would generate from a database for you 3 faces that become your passcode. You need to learn these faces, so they give you just little nudges to help you consolidate it. Things like, does she remind you of anyone? Okay. And then later on, you see her face in a grid, like a pen kind of layout, and you select it, and you go through multiple trials, depending on the degree of security that you need to be able to authenticate. What do they find? They find a 1/3 drop in login errors compared to alphanumeric, and this is even when, in this particular study, the users were employing alphanumeric at a much higher rate. Okay, so they're using this system less often, but they were still remembering it much better. So we see that graphical passcodes are more memorable. One of the things that we can point out to you right away is that they're using recognition versus recall. So she's there, right? One of the main problems with memory is not encoding, it's actually retrieval. We just don't have the right context to access that memory trace that we need to. Okay. The other thing is the picture superiority effect. So if we have alphanumeric information, it's semantic, and you're encoding that, but you're missing out on all the visual richness that you get from a picture. Okay? And that richer representation is much more memorable. Now, depending on how it's implemented, it can actually have stronger security. One thing is that it avoids reuse of passcodes, right? Because you have a database that's generating the code for the user instead of asking them to do it. The second thing is, depending on the class that you're asking them to discriminate within, it could be really hard for them to share their passcode with their family, friends, or coworkers, which is nice in social situations, like was mentioned earlier, because you might feel like, if I don't tell you my password, we don't have a good degree of trust. This is just, I can't tell you because I'm not able to describe it to you, right? Oftentimes in class when I'm trying to communicate this, I'll show people a particular picture of a robin and ask them to draw it and share it with other people. People are very terrible at drawing not only a particular bird like a robin, but that robin, right? You missed the little spot that was on the wing, right? But with any new implementation, and this is what's fun about cybersecurity, right? You have new attack vectors, new things you have to worry about, new vulnerabilities. And for this graphical authentication, it's over-the-shoulder attacks. And so we know we have a lot of different types of actors. So what I'm talking about here are really casual, opportunistic attackers. Okay, so maybe you're at the airport and this person's phone went dead. Human nature now, because we're so obsessed with screens, you look at the person next to you, right? And then you accidentally see their login. Maybe you're standing in line behind your mom, you see her PIN number, something like that, right? It's really easy. And the other issue here And I should say, with over-the-shoulder checks, well, it's easy for you to log in, so it's easy for the attacker to see it in a blink of an eye, right? The other part of this is a lot of these systems aren't designed for small screen usage. Now, this, in a way, it could be better than the current alphanumeric. Think about using a virtual keyboard with no haptic feedback and then having to shift between multiple boards to include things like symbols, right, or shift upper lowercase. It takes a lot of very good motor control, to fine degree motor control to do this, especially if you got big fingers like I do and trying to hit 2 buttons, okay? And bouncing around in a Jeep or something's even more difficult. So there's other use cases we have to deal with. So how in the literature are they dealing with over-the-shoulder attacks? There's 4 major categories here that we see. The first is grouping. This is like what we saw with the pass face, one face hidden amongst other faces, or camouflaging, right? Another thing that they do, and this is often in combination with camouflaging, is translating to another location so you don't actually select the target that is your passcode and give it away, okay? And I'll give you an example of this in the next slide. Next, you can degrade it. So here we have a picture of a baby. You know that baby picture. The system then extracts the baby picture. There's some random noise in the system that then you recognize that's the baby picture. Somebody that's not familiar with the original can't recognize the source, right? So it keeps it protected. You could use gaze-based input. This is looking forward a few years. But eye tracking's came a really long way in terms of low budget and high, quick calibration. So what you do here is you see these dots, and you have a gesture that is your code that you're putting in, or draw a letter or something with your eyes. There is no visual feedback on the screen, so it's really hard to be sitting behind somebody and get somebody's eye movements, right? So one of the more popular in this literature that talked about graphical authentication is the convex Hall click scheme. So this uses the camouflage and not clicking on the target in combination. So again, the system here generates 5 icons that are your passcode, and then you're given this fairly complex visual search where you have your icons scattered amongst others, and you need to find them and connect them. So there will always be 3 or more of these present, and this purple shade here is showing the convex Hall, but this is not actually shown on the screen. This is just a representation for ease, for you know what I'm talking about. So you mentally project that purple, and then you click on an icon within it. And you go through multiple trials of this, right? So research has started to focus on the usability of these graphical schemes in terms of login, error rates, memorability, satisfaction. Unfortunately, most of this research has been in the context of trying to pitch their own idea that they no doubt have a patent proposal in the office waiting, right? So what we've done in the lab is actually tried to benchmark the data, and so this isn't out yet, this is in progress. We're hoping to get it submitted this summer, and what we did is we did a runoff of each of the, we had those different ways of like camouflaging, not clicking on, and so on. Each one of those methods that kind of have a prototypical representation of it, and we ran it compared to alphanumeric passwords and looked at these within subject. And what do we find? Well, first of all, the graphical schemas are memorable. Okay, so here we're looking at some of the data. The yellow dotted line is the alphanumeric, just meeting conventional standards for strong passwords, and all the solid lines are different ways of authenticating with the graphical base. What we see with time 1, or I should say on the y-axis, we have error rates for logging in, being able to log in. On the x-axis, time 1 is, you just learned this in the lab, you're like a Psych 1 student, you're participating in a study. So you don't have a lot of motivation. You're just showing up for some class credit. And you're told a complex password, and then you're asked a few minutes later to tell me what it is. And you're near perfect at that. We see a little bit of cost and performance for the graphical, probably because they've never seen these. Well, they haven't seen these before in their lives, right? Now, what happens at time 2? We have them come back 3 weeks later. And again, you're just in the psych study. You don't really care. It's not really guarding your personal data or anything, right? You're nice enough to come back. What do we find? The alphanumeric, almost nobody can report it, okay? It's totally gone, right? Look at the graphical passwords, right? It's completely flat. They're performing the same, they have the same memorability as they had just across a couple of minutes. This is 3 weeks later, right? So pretty darn impressive, I think. What do we see as costs? Well, the first thing we see that it's slower to log in with these graphical schemas across the board. And learnability seems to be the downfall of these new schemas, right? So how do we get these out there? In terms of getting them accepted by businesses that push forward standard practices, we need to figure out a standard way of assessing over-the-shoulder attack resistance. And we've recently had a paper discussing this using the different methods that are out there. There's a variety of like 4 or 5 different ways, and we ran them off one another, and we do see differences in terms of how well something performs depending on the methods you're using. So we need some type of standard process to calculate resistance here to over-the-shoulder attacks. We need to be able to translate to small displays. This is, we're doing a lot more purchases through mobile devices and so on and so on. Okay, we're a mobile community. It's very ubiquitous out there. And there doesn't seem to be any human-centered guidelines until now, so we just got our paper accepted. It will be out this summer. So you can look at this. Go to my website and download it, please, and cite it, please, even more. So let me take you through not all the details, but just kind of the high points here. So first of all, whenever you're designing an authentication system or creating this gate for your company, you need to be inclusive. And there's some legal reasons you need to do that, but we won't get into accessibility issues here. They need to be inclusive of all populations. A great example, this is 2 years ago, the Social Security Administration thought, wouldn't it be great, we're going to validate these accounts through an SMS, multi-factor authentication. Within 1 month, they had to pull it down. Beyond the technical part of us knowing it's easy to spoof this information from fake phones, but how many people that are using Social Security not only have a cell phone, but have SMS turned on and use it regularly, right? So huge failure. We need to shoot for, according to Ben Snyderman, about 90% of our users. So we're not going to get everybody, right? And there's ways we can work around this, but about 90%. We can also, by having kind of an inclusive design perspective, we can make our products better. So if we think back to past faces, right, so that pin kind of layout of faces, they did a study and said, well, what happens rather than using young faces, we use old faces, and then we have older folks log in. You see that their performance goes up, right? So you probably know just big data-wise, relational data. You know if you have an older user, use older faces. It makes it easier for them to log in, okay? You could use tactile feedback for people that are seeing impaired. When you compare their performance on these systems to what I call normals, like people that can see normally, we perform just as well with the tactile feedback, and that prevents a lot of the over-the-shoulder attacks as well if these are, say, built into our phone vibration or something like that, right? Okay, so I need to set this next guideline up a little bit because it takes some expertise about cognitive psychology. And this is the idea that we have a limited awareness, and our working memory, okay, is our conscious kind of workbench that we work from, it's a limited capacity, so we need selective attention to pull information into that workbench. So we deal with this new information in this kind of limited workbench way. People are usually like, what are you talking about at this point, okay? Well, as we sit here, you feel like you have a very constant, complete, full representation of the environment that you're in, right? So you know everything that's going on around you, and the military we call it situation awareness. So you know all this stuff around you, right? It's stable, it feels real. But in reality, most of what you're experiencing is in your head. It's fabricated, and we're only getting fragments from the world. But you probably still don't believe me, so I can demonstrate this. And we usually demonstrate this through the change blindness paradigm. So we have 2 images, okay? And you'll notice that they're slightly different. Your job is to find what's different. This is like the old movie scenes where they had the cutaway and they came back and there's a package of cigarettes or a Coke can or something, right? And they're all you can go look these up on the internet. So you see that the height of the wall changes, right, behind the statue. So there's a picture, there's a flash, and there's a picture. If you do get all the information in the environment at once, you should be able to see the one picture, pick up all the information stored in memory, go to the next picture, pick up all the information stored in memory, and instantaneously know what's changed. Like instantly, within 1 second, your first viewing of seeing this, right? However, if you have to go to one small fragment, pick it up, store it in memory, go to the next picture, same location, pull a fragment, store it in memory, is it the same or not? No. Or the same or not, it is the same. So then you have to go back and search and search and search. You should feel your attention moving around effortlessly through the scene. That tells you that you're only getting fragments from the scene. So I'm going to show you an example of this. Okay, if you've seen this one before, this gift, stay out of this because you'll ruin it for me because you've seen it. But if you haven't seen this before, really try as fast as you can to find what's changing and raise your hand when you see it. Okay. Okay, get ready. Okay, so I see no hands yet. So we must be fragmenting this. Okay, got a hand. Especially people in the Air Force should be getting this. This is an important feature of the object. It's kind of fun when you find it, right? You're like, how? It's kind of surprising. How did I miss that, right? Look at the engines. Look at the engines. This is a really important feature of this object, the aircraft, right? We're missing it. So a lot of the world around us, okay, is based on expectations, previous experience. We've consolidated these. Okay, we're activating schemas from our context that we're in. And we're only getting little bits of information through our selective attention to optimize the tasks that we're completing right now. And then we're going to try to work and assemble that information in working memory so that we can push it offload it into an automatic process. So what should designers do to or avoid draining users' limited working memory resources, right? Well, first of all, you should strive for interaction consistency. So think about a keyboard, okay? It took a lot of effort to learn where all those keys are. Can you imagine if somebody started moving those keys around on you, right? Made it variable? It'd be very frustrating. But now you don't have to think about those keys. You can construct a paragraph that's a letter to somebody conveying an idea. There's actually a cost for non-keyboard users that complete assessments of their ability when they don't know how to type, because they think about where's the key and they're pecking this out, and that drains cognitive ability, makes them look dumber, okay? We want to employ recognition over recall, which we talked about, and we want to facilitate visual relation encoding, like the picture superiority effect we talked about. The next thing is our users have incomplete mental models, okay, about this interaction. So I stole this from MSN Money blog just a few hours after there was a news release about a massive hack of 2 million passwords. And this is what she said. The top content got 70 thumbs up, right? So everybody was behind her on this. Why in the hell would anybody want on my Facebook for anyway? Other personal stuff, email or bank account, I understand. What are they going to do with Facebook? Put up a post for you or look at your pictures, okay? So here, clearly the user does not understand the value of her personal information being used against her in a social engineering attack, right? I mean, especially with all of these, I lost my password, and psychological questions, right? What's your dog's name? Right? What's your best friend in high school? Stuff like that, right? You can get that stuff from here. As soon as I compromise, say, your email, I can then send a request out to all your other accounts. Hey, go ahead and send me your password. So once I get your email, I own everything that you own, right? So this stuff actually is really important, but people don't really perceive this as being really valuable. So what we need to do, and I've heard this as really a constant across cybersecurity in general today, we need to inform and educate our users about risk. So users must be aware of the risk associated with information. They must be aware of security policy. In other words, how do you want me to deal with it since we're in a partnership, especially with bring my own devices, bring your own device environments that we're in today. And here's the last piece, which we usually don't see. How can we be accountable for those actions, right? And we can do that in some creative ways. And they don't have to be negative. You don't have to give tickets. You can give prizes, right? Positive reinforcement. People protect information when you're trying to attack to test your network's integrity, and people do a good job, just give them $100, right? It's a much better way than showing up and telling them they owe you some money, that they owe you some money. Okay. We need to, so users can either bolster or undermine security depending on their appreciation for the risk. Unfortunately, we often perceive ourselves to be at less risk than the average user. And I love talking about this in terms of decision-making chapter in my general psychology class. I'll tell everybody in class, okay, look around, everybody in the room, there's like 100 people, okay? Raise your hand if you think that you're smarter than the average person in this room, right? And everybody raises their hand. And statistically not possible, right? You see that, right? And people looking around, well, but I'm definitely smarter, It's the same thing with security, right? So we have these kind of same principles in play here where people think, well, I'm more secure. I'm not the victim. I'm not going to be a victim. So we need to communicate risk and to help the users to behave proactively. There are partners in this. Just like we design a system to help them to do their job, we got to partner with them. And I know this is a big change in history, really in recent history, where all the security features were buried, and the administrators took care of it, and now all of a sudden, it's such a rich and complex environment that the users have to be proactive and play a role. Okay, so how do we do this? We have personalized training, and this could increase their motivation to comply. All right, so I think there's a researcher at the University of Maryland that did this thing called Lollipop, where they pulled down people's pictures from Facebook and other things to put into their security training materials. We can give timely notifications. We have a great security person at ODU that sends out emails whenever there's a certain type of attack happening, just to keep us in the loop and educates us on it, right? Here's what's happening. This is what I'm talking about, in a very simple but useful way. You need to use standard terminology in terms of risk. And the literature, they talk about kind of security levels as being low, medium, and high. And this also, I think, going forward in the future too, in terms of cyber, as I was talking about earlier, is kind of breaking up the information and having different degrees of risk tied to that rather than across the board. Okay, focusing on authentication. Don't distract from the primary task. So authentication is always a secondary task to the user. Okay? Often a lot of security is as well. It's just simply an interruption in meeting their goals. So if you think about going to a website and buying a bike tire, right? So you just want to get the cheapest tire from a company that you can trust that's going to get it to you, okay? If they then say, you need to become a member, you need to set up this two-part authentication in this phone, what are you going to do? You're going to back out and go to a competitor that doesn't have that, right? So they're going to abandon the cart. So that's a big problem for a company. We need to consider what's going on in terms of working memory that they're assembling. If I'm in my office and I got this student that is in my class, I don't know them, so I'm trying to remember their name, first, last name, how it's kind of spelled. It's usually it's new names and students are so weird. So I'm trying to remember those names, and there may be their ID number. And at the same time, I got this new password I just had to update for ODU, and it's this really weird, strong password. And now I'm trying to remember that too, and now I'm getting interference between the two information sources, right? So we probably won't have one solution. We're probably going to consider the user's task and the representations they're operating on, so we don't cause interference. Another thing in the literature that I saw from this 06 paper in particular emphasized when they created their solution that it needs to be fun, and that's really important. And who logs into their computer just to log in? Nobody, right? That's ridiculous. So we don't want it fun. That shouldn't be a design consideration as we're going forward. Okay, we want to provide users quick access. So users want to get beyond authentication to the services that they're trying to use. And I believe that this quickness is going to be associated with perceived quality. How do we do that in terms of a service? Well, if you think about like internet service, Snyder has done some great work on this too. You have your expectation, your conventional use, right? So one of the great things you can do if you're an internet provider is to throttle your network during fast time so they never get to experience that sweetness, right? And so then you keep it constant. That's a good quality of service, experience from if technical people are like, wow, why would you throttle it? I want to download all this stuff. Well, it's about the experience that you're providing, the perception, right, rather than the pure numbers overall. So what is the benchmark here? Well, if we look, the conventional passwords take people 7 to 20 seconds to log in, and PINs 5 to 10 seconds. Some of these graphical authentication passwords or passcodes require multiple rounds, and that can take up to an average of 72 seconds, right? That's way, way too slow, right, for a solution. So we need to get to less than 20 seconds. So here's an overview of most of the guidelines here, okay? And in our lab, we've came up with a few solutions we believe meet these requirements, but I'm not here to pitch anything like software today, okay? But you'll see those come out as well. I'd like to thank my collaborators. Ashley Kane's in the room over here. She's my PhD student doing a lot of the cybersecurity stuff. And then numerous undergraduates as well. Again, if you've seen a paper that you're interested in, jump out to our website and see if it's there, psychofdesign.com, or just send me an email and ask me for it, or to send it to you whenever it does come available. But now I'll turn it over for questions. So, yeah. Yeah, so he's, and then this is in terms of the convex Hall click schema, or just overall? Yes, overall. So, it sounds like you're asking, so what in terms of object recognition, what are we doing process-wise? Are we looking at the features as a whole? And I think this goes back to the figure ground segmentation literature and perception. And this is something that we don't have quite figured out. A lot of it has to do with your experience. So a great example of this, I think, would be if you have a frog printed on the back side of a coffee cup. Is that frog like a separate object in the coffee cup, or is that texture then integrated with the coffee cup, right? It depends on the task, and that's when attention plays an important role. And that's why where a lot of artificial intelligence solutions fail, because they're not set up to handle tasks, just to segment and then to classify within the set and to separate. But so if we engage intention in trying to recognize all the cartoon characters in a room, we would recognize most likely the frog as being a separate important object. So I don't know. This is kind of a bigger philosophical kind of thing, but yeah. Or go ahead. Yeah.
You know what goes with what Mr. Freeman was saying, not Freeman saying what you're saying. So you had this example where people don't believe that their Facebook information is that important.
Mm-hmm.
And so, for example, when we normally do a test, say like a red team test or a penetration test at a large corporation, we'll run it against the security team. And so the security team has, I'll just give you a ratio, like what would be the ratio that they click the phishing email as compared to the regular population. Now you're a scientist, take a guess, what's the ratio? Is there a difference?
You know, I'm not that familiar with the phishing attack literature. Yeah.
It's exactly the same. You get the exact same incidents. Okay? And so training someone, the idea that you're going to, and this is the worst part of that, I'm going to scare my users enough that they don't want to share their information, that's a horrific idea. From the social aspect, I'm never going to go with that. But also the idea that you can may not be true. So the question I would ask for that then, go ahead.
Yeah, I don't think I'm advocating for fear-mongering, but rather education. And one of the ways you can educate students best is to contextualize it in their context. So if I tell a story about students, about, like I just in class, we talk about persuasiveness. I talk about how to pick up women at a house party. And I talk about how do you become more attractive and blah, blah, blah. And guess what? Those students are on the edge of their seats because I've contextualized it for them, right? Sorry.
So what my data that I provided to you, which may or may not be conclusive to you, is that the person who's completely educated about it, the expert security industry people are just as susceptible and vulnerable to these flaws as non-experts. And so that basically diffuses any idea that you can convince someone through education, because they're the most educated in the world on the failures of the system. And so that people may not be designed memories in this way.
Yeah, I think that it depends on the attack. I mean, if you look at somebody that's well-resourced and well in the loop, they're going to get in. They're going to get over, all right? And we have to deal with that in terms of how do we make an example out of them. This is when the military comes in, make sure that there's repercussions to this, a well-funded, well-resourced thing. But in terms of just kiddie scripts, everyday attacks that are pretty canned, we should be able to educate people enough to recognize these predictable attacks that are pretty strict. But I agree. If it's like well-resourced and well put together, anybody's going to fall victim. Because if it looks identical to your bank, but there's an O rather than a 0, I mean, how many people are going to fall? And it depends on the browser you're using. Sometimes you can't discriminate those things.
So just to finish that, that's the same problem we just came from.
Yeah.
You've now separated security out to another group and we're the exact same problem we were before. That's I'll stop there.
Yeah. So, yeah.
So I guess when you started bringing up your example of asking the students, who's smarter than average, it kind of made me think of the Dunning-Kruger effect, which is where people who really are more intelligent tend to underrate how intelligent they are, and average and below average people tend to inflate how intelligent they are. So where I'm going with this from a cyberpsychology perspective, it suggests to me that if you train a group of people, the people who maybe have more intellectual prowess are still going to feel like they're undertrained and they need to learn more. Whereas the lower than average people are going to think, hey, I'm solid now. I really know my stuff. And so that kind of gets you into the situation where no matter how much you train more susceptible, weaker-minded, however you want to characterize it, people, they're still going to be susceptible, more susceptible than those who maybe are more intellectual and think no matter how much training they have, they don't know enough, and so maybe they're going to be overly cautious. Do you have you done
Yeah, no, I've never been a huge advocate of training. I think that a lot of times in cybersecurity, we never even communicate once what's going on, and that's what I'm talking about. I think we need to design out the problems. So if we can look at the mistakes that people are doing, let's circumvent those altogether. And we can do that through this human-centered redesign process. And so that's the first priority. So that's what I was trying to do here with the human strengths and weaknesses. If we know that alphanumeric's not really working in all these ways, there's probably other solutions. And I'm not a big advocate of biometric, just because, well, look at the government. A lot of government workers now, biometrics are exposed on a server. All information on a server will be exposed eventually. The question is, you can't redo your fingerprints. You can't update your fingerprints, right?
Yeah, and I'm really worried about somebody like cutting my fingers off because
Yeah,
I
yeah.
watch much TV. I'm really scared about it.
Well, and there's some research that shows that it might actually, and it might also reveal something about your health as well, your genetics. And so this relational information that's tied to this could be revealed too much. So, any other questions? Yeah.
So it seems the trend in all of this is to put more and more and more requirements on the individual users. By the way, I must be like the dumbest person on the planet.
Right. So this isn't human-centered in terms of this is all on the human's shoulders. It's human-centered in terms of they're an important stakeholder in designing the system, right? So if I understand how you think and behave, I can design a system that's more intuitive for you and to hopefully make it so that you don't make as many errors, right? That's what I'm talking about for the human-centered. And I know right now there's a big push, and I know like in the Air Force and other areas, to make everything automated, okay, and to not have humans. This is not possible. We all interact with the automation, and we have to interpret the automation data and make decisions, so we'll never take the human out of the loop. But what I'm seeing and I'm worried about is all the funding money that's being put into technology first as an arms race, and then worrying about the users afterwards. And this is not how you build systems. No Fortune 500 company out there does not have a user experience division that's helping lead product design. So, questions? All right, thank you.